In this video, I will be explaining an overview of how to write list terms and determine the rules of sequences and summation notation. Now, a sequence is a function whose domain is the set of positive integers. Now, a long time ago, we talked about the difference between integers and whole numbers and natural numbers. And in a positive integer is going to be a 1, 2, 3, 4, 5, 6, 7, and it will go on forever. So you're not going to input decimals, you will not input square roots, you will not input fractions. You're only going to be inputting in actual integers. So the first thing that you're going to be asked to do is to find the first 5 terms of the following sequence. So they're going to they have given you a formula, and what they want you to do is to plug in to figure out what the first 5 terms are. Now, positive integers are going to be starting with 1. So if I find out, I want to know what is a of 1, meaning I am plugging 1 into n, then I would plug in 1 into n. 2 times 1 is 2, minus 6 is negative 4. And then I want to know the second term, so I'm going to plug in 2 for n. So I'll get 2 times 2 minus 6. 2 times 2 is 4. 4 minus 6 is negative 2. Then you would plug in the third term, which is 3. So I'm going to plug in 3 for n. 2 times 3 is 6. 6 minus 6 is 0. And then plug in the fourth term into n. 2 times 4 minus 6. 2 times 4 is 8. 8 minus 6 is 2. And then to plug in the fifth term means you plug in 5. 2 times 5 is 10. And 10 minus 6 is 4. So the first 5 terms of this sequence would technically be negative 4, negative 2, 0, 2, and 4. In the second instance, you'll do the exact same thing. If I want to know the first term, that means I'm going to plug in 1 for n. So I'm going to get 3 plus negative 1 to the 1. 3 and negative 1 give me 2. The second term means I'm going to plug in 2 for n. And then negative 1 squared here actually turns to a positive 1. So 3 plus 1 gives you 4. And then when I do the third term, that means I plug in 3 into n. Negative 1 to the third power is actually negative 1. Basically, any odd power is going to give this an odd, it will give this a negative number. So 3 and a negative 1 will go back to a 2. The fourth term means I plug in 4 into n. Negative 1 to the 4th power is positive again. So 3 plus 1 gives me 4. And then the fifth term means I plug in 5 into n. Negative 1 to the 5th power turns negative again. So 3 and negative 1 go back to 2. So if you were to write the order of this sequence, it's actually 2, 4, 2, 4, 2. Now, there is something called a recursive sequence. It is a sequence in which terms are defined by one or more previous terms, meaning, in this case, they want to know the first 5 terms of the sequence. Well, you already know the first term. It's 3. So here's what you're going to do. This is going to seem a little odd, but I'm going to do it algebraically first, and then I'm just going to kind of explain the words. In order to find the second term, I need to plug in 2 for n, which means if I plug in 2 for n, 2 minus 1 is 1 plus 1. So the second term is going to be found by multiplying 2 times the first term and then adding 1. Well, we know the first term. They gave it to us. Basically, they had to. You wouldn't have been able to do the problem. They didn't. So the first term was 3. So 2 times 3 is 6. 6 plus 1 is 7. And we found the second term. So to find the third term, that means I'm writing a of 3. And that is 2 times a. And in this case, I am plugging 3 in for n. 3 minus 1 is 2 plus 1. So to find the third term, I'm going to multiply 2 times the second term, not 2 times 2, but 2 times the second term, and then add 1. Well, the second term was 7. So I'm actually inputting 7 here. So 2 times 7 is 14. 14 plus 1 is 15. To find the fourth term, I don't know if you've noticed the pattern yet. Basically what you're doing is you're taking the formula and you are multiplying 2 times the previous term and then adding 1. Well, the previous term was 15. 2 times 15 is 30, and 30 plus 1 is 31. And so to find the fifth term, I'm going to multiply 2 times the previous term, which was 31. 2 times 31 is 62. 62 plus 1 is 63. So the first 5 terms of this sequence is 3, because that was the first term, 7, 15, 31, and 63. Next, summation notation. This is a notation that you will see in the future. This is sigma, is the Greek letter, and it means the sum of a certain type of either some type of series or some type of sequence, basically. The number at top is the upper limit. The number on bottom is the lower limit. 6 doesn't mean it wants to know the first 6 terms. 6 means that you keep plugging in numbers until you actually reach 6 to be able to plug it in. So in this case, you're going to start with 0. So I'm actually going to plug in 0 into my variable. And then I'm going to plug in 1 into my variable. And then I'll plug in 2 into my variable. I'll plug in 3 into my variable. 4 into my variable. 5 into my variable. And 6 into my variable. And that's where I stop because I've reached my upper limit. And now you actually add all these together. I may need a calculator, I'm not sure. Obviously 3 times 0 is 0. 1 squared is 1. 3 times 1 is 3. 2 squared is 4. 4 times 3 is 12. 3 squared is 9. 9 times 3 is 27. 4 squared is 16. 16 times 3 is 48. 5 squared is 25. 3 times 25 is 75. 6 squared is 36, and I believe it's 108, and it is 108. Now we add these together. So 3 plus 12 plus 27 plus 48 plus 75 plus 108 gives you your answer of 273.